See, now it works. Now it knows I'm from Pakistan. No use. No rest at all. Okay. We started the topic of level of service and capacity last time, and we discussed that we follow the highway capacity manual for these analysis, and we also discussed the official definition of capacity according to the manual, and we looked at these values, which are the values of capacity under ideal conditions. So now move on to the concept of level of service. Okay. Now we know traffic does not behave in the same way when the volume changes, right? If the volume is 100 and the volume is 2000, okay, will the traffic flow be same in both cases? 100 and 2000, different, right? Okay, so the nature of traffic here is different and here it is completely different, right? Does it change only between these two extreme values? Meaning, if the traffic flow is 100, okay, will it remain the same until 1999 and only change at 2000? It will keep on changing, right? Okay, so it is something at 100, something else at 500. Now the condition of traffic at 500 is not the same as 100, right? And it is also not the same as 2000. So there are different conditions of traffic, different states of traffic flow. Okay, these states or these conditions are represented with level of service. So what is the level of service? A condition of traffic under a given value of volume. When the volume will be this much, traffic will behave like this. Okay, so this is represented with a level of service, LOS. Okay, now why do we want to use it? You will use it in our design. You will see that. So, for example, you have the lowest level and the highest level, right? The lowest level is 100, the highest level is 2000, whatever, capacity. The highest level is capacity, right? Okay. Now you are designing for the peak hour. What are you expecting in the peak hour? Are you expecting the lowest level of traffic? Or are you expecting the highest level of traffic? Highest level, right? But are we expecting capacity? Are we expecting capacity in the peak hour?
No, expecting something beyond capacity.
You are expecting something beyond capacity, then is it a good design? If you are expecting something beyond capacity, then is it a good design? I am expecting on this building to have a load of 2 tons. Will I design it for more than 2 tons or less? More, right? Same applies to the road. Okay. If you are expecting this much volume, then the capacity should be what? More than that or less than that? More, right? Okay. What if it is equal? What if it is equal? The actual and the capacity, they are equal. Is it a good thing or no? No, why not?
Potential of overflow.
Potential of overflow. Yes. There is potential of overflow, potential of breakage or potential of failure. There is no margin of error now. If it is exactly capacity, there is no margin now. Okay? Anything can happen, right? In the real world, anything can happen. So if you are, again, taking the example of the building, if you are designed for exactly 2 tons, maybe somebody will bring an extra bag with them. Today we will not bring tablets, we will bring our bags. And each bag like 1 kilo of laptop. Right? So 1 kilo for everybody. You can imagine, 50, 60 kilo more. So because of the laptops, the building can fall, right? Right or wrong? So there is no margin. So we need to keep a margin. So we are not designing for the lowest level because that is useless. We are not designing for the highest level as well. We are designing for something in between. Okay, so we need all the level of service. We need all the level of service, not the highest one, the lowest one. We intermediate ones as well. Okay. This concept was given in 1965 highway capacity manual. They first came up with this concept, and to make our life easy, there are 6 levels of service. Very easy to remember because they go from A to F. This is your life for 4 years, right? A to F, F to F. Right? Okay. So this is the official definition of level of service in highway capacity manual. And the first letter, the first sentence I already mentioned to you: quality of traffic flow, quality of traffic operation under a given value of flow. When the flow is this much, the quality of traffic will be this. Okay? Or the operating conditions, the quality of operating conditions. Traffic is how the traffic is moving. Operating means how the traffic is moving. So the condition of movement of traffic under a given value of flow. Okay? And it's a qualitative measure. It's a quality measure. There are 2 types of measures: quality and quantity. Quality and quantity. Okay? If I ask you about the weather today, okay, and you tell me the temperature is this much, you give me a number, right? Is that quality or quantity? Quantity, right? There's a number. Okay? If I ask you about the weather and you say it's very hot today, is it quality or quantity? Quality. You get the point now? Okay. Now, why do we need a quality measure for traffic? Why do we need level of service? Did we discuss any quantity measures for traffic earlier? In the earlier topics, did we discuss any quantity measures of traffic?
Yes.
We discussed, right? The data. For example, the demand, the volume, the capacity. All of these are what? Numbers, right? All of these are numbers. They are all quantities. We discussed speed, travel time, delay. All of them are what? Quality or quantity? The speed is what? Quality or quantity? Quality. You will give me a number, right? The speed is this much. So all of them are quantitative measures. If I have these quantities, why would I go for level of service? Why do I need it? Okay, because there are certain things about traffic which you cannot measure. Okay, which you cannot measure. For example, the first 2 things we can measure, right? The first 2 things we can measure them. Speed and travel time can be measured. But what about this? Freedom to maneuver. Can you measure freedom? Which is a good thing, right? Which is a good thing. All of us think we are free, right? All of us think we are free. Because we cannot measure it. Right or wrong? This, my friend, see? You take this class and come here. You cannot stand outside. See, is this freedom?
No.
You cannot measure it. You are completely free. Okay? Alright, freedom cannot be measured. Okay, but it's part of the driver behavior. Traffic interruption. Interruption means what? When we say uninterrupted flow, we mean what?
If there's an intersection.
Intersection, right? You can measure intersections. How many intersections you can measure. But what about comfort? What about convenience? You cannot measure these. Okay, somebody may be living in a big mansion and having air conditioning and so on, and still he is not satisfied for some reason. Okay, but he still has all these things. If he gives them to us, we will be satisfied, right? He will be happy because of our dua, right? Right or wrong? So we need to find that person and we will tell him. Okay, but these things, now you get the idea, it cannot be measured. Okay, so these things, all these things which are mentioned here, measurable or immeasurable, quality or quantity, all of them combined in level of service. Time, speed, interruption, comfort, convenience, freedom, all of them are combined in level of service. So that's why we need a quality measure. Now, freedom for who? Driver. Convenience for who? Driver. Okay. Comfort for who? So you see, things related to drivers are difficult to make. That's why we need the concept of level of service. Because drivers are dictating, right, how the traffic will move. So that's why. Okay, I told you level of service goes from A to F. A to F. Okay? But here it only goes up to how much? E. Now what is written at E? Tell me. Capacity. Okay? Capacity. Okay? So, and capacity means what? How do you define capacity?
How much this segment is able to take?
Maximum, right? Maximum. Maximum. Okay, what about the next one after E?
Maximum sustainable flows.
So why they are saying it's D, right? So why did they say maximum with E? E means capacity, right? And capacity is maximum. So why they are saying D is maximum flow? E is also maximum flow. Let me get it clear. E is also maximum flow. E is maximum flow. E is maximum flow. And D is what? Maximum sustainable flow. So E is maximum flow, D is maximum sustainable flow. Okay, there's a difference between them. Sustainable means continuous, without stopping. Okay, without any interruption. When you reach capacity, it's completely full, right? So what did we say about when it is completely full? When you reach the capacity, there is no margin for it. There is no margin for it. So because of driver actions, the flow does not remain sustainable. In E, the flow is maximum, yes, but it is not continuous. A driver changes the lane, everybody stops because there is no gap for him. Right? We are at capacity. You know the meaning of capacity, right? Okay, like all this space is full of chairs. If I have to move, I will do what? I have to move the chairs, right? This is what happens at E. All the lanes are full, they are moving, but all of them are full. If I want to change my lane, if I want to go on the shoulder, okay, or there is a parking area, I want to go into the parking area, I have to stop others. Okay, so E is maximum, but it's not sustainable. D is maximum, sustainable. Got it? Yeah. And then we have B and C, which are defining as practical capacity in rural areas and urban areas. Okay, and then we have E, for which you dream, right? A, sorry. A is a good one, right? You want an A or not? Huh? Why are you so worried? What happened? What happened? Nothing? So A is when it's free flow and everything is good. Okay, now what about B and C? B and C is practical capacity. Okay, practical capacity means what? I will give you an example here. I just did it in the first topic as well. Okay, and I showed you with the graph. Usually, when the flow is very low, when the flow is on the lower side, your speed is higher. You maintain a high speed, but the flow is not constant. The flow is changing gradually, but you don't feel it. So you are still going at high speed. The flow is changing little. You don't feel it. So you are still going at high speed. Okay. So this is like this. Flow is increasing, but the capacity is constant. Oh, sorry, the speed is constant. Flow is increasing, but the speed is constant. Okay. You will start to feel the effect after a certain time. Now the vehicles are too many. I should slow down. Okay. This is the point which we call as practical capacity. So after this, it will not go like this straight. It will go down. So flow is increasing and the speed is reducing. So the point where this happens, this is called as practical capacity. So before this point, the change in speed is very negligible. It's almost none. But the flow is increasing gradually. But the drivers are still maintaining high speed. Alright? Yeah? Okay. So in urban areas, it's related to level of service C. In rural areas, it is related to level of service D. Okay, C means higher flow. Okay, C means higher flow, B means less flow. Okay, so in urban areas, traffic is usually higher. Right? So people are used to driving with high speed and with high traffic. In rural areas, traffic is usually low. So even when the flow increases little bit, people start to feel it because they were not expecting it. Okay, when I come on the road, I always see so many vehicles around me. I'm used to it. In urban areas, in rural areas, I'm not used to it. Okay, so in rural areas, the change in speed happens early with less flow. In urban areas, it happens later. Okay, because of the expectation of the driver. Got it? Clear? Okay. One more thing, capacity is, yeah, okay, this is what I mentioned. Okay, so, level of service is a quality measure. So it's a letter, right? Like your grades. You get it as a letter, right? A and B and C. Okay. So can I say, okay, A for you, B for you, C for you, D for you? Can I do that? Yes or no? Yes, I can do it, right? Everybody agrees I can do it, right? Okay. Remember that. Okay, nobody comes to me after this. No, nothing. I can do that, right? Okay. But no. To give you the B, I must have a score, right? To give you the A, I must have the score. Okay? That score is a value. It's not a letter. The score is this much, it's a number, right? The number is this much, your letter is this. Your grade is this. Same thing happens with level of service. To find out the level of service, I need a value. To go to the level of service, I need a value. And that value is called as service measure. Okay? So service measure is the value which will get you to level of service. Okay? Service measure is the value which tells you the level of service. Got it? Okay? Now, we are discussing uninterrupted flow facilities. We will discuss three of them: multi-lane highways, freeways, and two-lane highways. For multi-lane highways and freeways, the value which we need for level of service is density. For multi-lane highways and freeways, both of them, the value which we need for finding out level of service is density. Somebody asks you for level of service, you would ask him what is the density. Give me the value of density, I'll give you the value of level of service. Clear? Okay. For two-lane highways, there are two things mentioned here, but both of them are related to speed. For two-lane highways, you are focusing or your level of service is based on speed on the road. Okay. Clear? For intersections, it is based upon delay. For intersections, it is based upon delay. Okay. Now, in one of the previous topics, we calculated the delay for signals and roundabouts with the travel time. Okay, we did. Okay. Why did we do it? Because we need it for level of service. Alright. Okay. So intersections delay, multi-lane highways and freeways. What was it? Density. Two-lane highways speed or related to speed. If the facility is for other types of users, not for traffic. For example, a bus system, a train system, okay, a pedestrian bridge, a sidewalk, a bicycle lane. It has nothing to do with traffic, right? So the service measure is not related to traffic. Okay, they are given in the manual, they are separate. But the point, we will not cover them obviously. But the point you need to keep in mind that the service measures, the values for level of service of these facilities which are not used by vehicles, they do not depend upon traffic data. Okay. So if I ask you for level of service of a pedestrian bridge, you will not ask me for density and speed and volume and flow. Got it? Clear? Okay. Now we said level of service changes according to what? What makes the traffic change? Flow, right? Okay. Flow. So level of service is changing according to condition of traffic, and the condition of traffic depends upon flow rate. Okay. So every level of service has a maximum value of flow rate. Every level of service has a maximum value of flow rate. Okay, that value is called as service flow rate. Okay, so service flow rate is the maximum value flow rate for a particular level of service. Okay, let us take the first one. First one is A, right? Okay, now if I say the service flow rate for A is 500. Okay, the first service flow rate for A is 500. So until you reach 500, you are in A. When you cross 500, you are in somewhere else, not A. What my point? Okay, so from 0 to 500 it's A. Now let's say service flow rate for B is 700. 700. Okay, so until you reach 500, you are in which level of service? A. A. After you cross 500, until you reach 700, you are here in B. Got it? Clear? So every level of service has a service flow rate. Okay? So you can see it goes up to E. And what did we say? E represents what? Capacity. Okay? So whatever service flow rate we have for E is capacity. Clear? Okay? And what about after E? Do we have a value after E? No. Why not? There will be a Q. Because we are asking for what? Maximum flow rate, right? Can we have maximum flow rate in F? No. F is a Q. So F means that the flow rate is now decreasing. Okay? So there is no maximum flow rate for F because there is the flow rate is not going up. Okay. Whenever you want to convert flow rate to volume, you need peak hour factor. Whenever you want to convert volume to flow rate, you need peak hour factor. And this is the equation over here. Flow rate multiplied by peak hour factor becomes volume. Volume divided by peak hour factor becomes flow rate. Okay? This is general. Flow rate into peak hour factor is volume. General. Any flow rate. Any flow rate into peak hour factor becomes what? Volume. Okay? General. But if that flow rate is the service flow rate for A, then the volume will also be service volume of what? Okay? So all levels of service have their maximum flow rate, service flow rates. You multiply them with peak hour factor, it will become volume of that flow rate. Oh, sorry, volume of that level of service. Clear? Okay? So in the example which I gave you, if I put 500 here and multiply by peak hour factor, then the volume you will get will become service volume of A, because 500 was the service flow rate of A. If you put 700 here, multiply by peak hour factor, the value will become service volume of B. Got it? Clear? Okay, in this chapter we will discuss freeways and multilane highways together. What's the reason? I will come back to it. Okay, but we are discussing freeways and multilane highways together. Okay, freeways don't have intersections. Freeways have medians, and freeways have at least 2 lanes in each direction. Okay, at least 2 lanes in each direction means at least how many total? 4. Clear? Okay, so freeways don't have what? Intersection. Freeways have what? Median and at least 2 lanes in each direction. Okay, or at least 4 total lanes. Clear? Okay. So everything is fixed. There are no intersections. The median is there. So only need to know the number of lanes. You only need to know the number of lanes. Multi-lane highways, they have intersections, but to call them uninterrupted, the intersections must be more than 2 miles. If they are less than 2 miles, they are not here then. You cannot discuss them here. Okay, so to have multi-lane highways as uninterrupted, the intersections must be more than 2 miles. Okay, multi-lane highways can have median, or they may not have median. If they have median, we call them divided. If they don't have median, we call them undivided. Okay, but the third condition is same, that 2 lanes or more in each direction. Okay, the third condition is more than 2 lanes in each direction. Okay, so multi-lane highways may have a median, but to become uninterrupted, multilane highways may have intersections, but to make them uninterrupted, the intersection must be more than 2 miles. Okay, they may or may not have median. Okay, with median divided, without median undivided. And the last thing is number of lanes. Number of lanes, at least 4 total. Yeah. Okay. Now, why we are discussing freeways and multilane highways together? Because both of them are depending upon a curve which is called as a speed flow curve. This one. Okay. Here I have flow and y-axis I have speed. For multilane highways and freeways, both of them, I need this curve. For multilane highways and freeways, I need this curve. Okay. So they follow the same method, follow the same procedure. Okay. Another thing which I need for both of them is free flow speed. In both cases, I need free flow speed. Okay. Now I mentioned this point here, right? After which the speed decreases. For both of them, this point is around 1000. Okay, or at least 1000. So speed reduction for both these highways, it starts to happen after 1000 passenger cars per hour. Okay, so in these cases, these are the things in which they are same. Another thing which makes them similar is the base condition, meaning ideal conditions. Base or the ideal conditions. I mentioned the base or the ideal condition in yesterday's lecture as well, when I was showing you the capacity. Capacity was in what terms? Anyone? Look at the first sentence here. No heavy vehicles. The first base condition is no heavy vehicles. So all vehicles are what then? Cars. This is the first condition. All vehicles are cars. Okay, passenger cars. And then second condition is about the drivers. All drivers are regular, familiar drivers. All drivers are regular or familiar drivers, meaning they know the road, they know the area. They know when they have to change the lane, they know when they have to take the turn and so on. Got it? Okay. So why they are kept as the base condition? Because these conditions give you maximum flow. These conditions gives you maximum flow. Heavy vehicles are slower, right? So if you have heavy vehicles, the flow will not be maximum, it will be less. Okay. And same thing with the new driver. New meaning the ones who do not know the highway or the area. Okay. So familiar drivers, they know where they are going. Something we should all know, right? Where we are going. Agree? Okay. So the drivers should also know where they are going. The drivers who regularly travel on this highway, they go faster. Okay. Drivers who are new, either they are new in driving or they are new on the highway, they are slower because they are new, obviously. Okay. So the base conditions give you maximum flow. Okay. Okay. A small description of each level of service. Level of service A means you have complete free flow. You are not bothered about other drivers. You select your own speed. Okay. Something is problematic with your car. You want to change the lane, you can do it easily. Okay. You want to go to the shoulder because the car stopped. So now you have to get out and push your car towards the shoulder. Okay. It happens, right? Okay. This will not affect the other drivers because they have enough gap available to go to the other lane without any stoppage. Okay. So in level of service A, the gap is very long. So changing the lane, and even if the lane is blocked, you have enough space on the other lane. Got it? Okay. And to give you the idea about the spacing, the average spacing in this condition is about 480 feet. Okay. Level of service B, more cars. Okay, you see more cars in front of you. The spacing is less, so you are now more careful. Okay, you are now more careful. Okay, but obviously you still live in Bahrain, so you feel like I'm the Formula 1 driver. Okay, I'm going straight to the track from now. So you see more cars, you see lesser spacing, but it does not affect your speed. Okay, so only your mental carefulness has increased. Your driving behavior is still the same. Okay, same speed. Still, there are gaps available in the other lane. Something happens to one of the lanes, an accident happened, the car broke down, or you wanted to change the lane, you forgot you were taking a turn, now you want to change the lane. You can do it easily. There is enough gap for you to do all these things without any stopping. Clear? Okay. The spacing, but the spacing is less. It was 400 something, now it is 200 something, almost 300. Level of service. See, more cars meaning less spacing. Okay, so from 293 to 233. Okay, so spacing is becoming less, but we are still in the F1 mode. Okay, we are still in the F1 mode. Okay, so we are still going at the same speed. Okay, so because the gap is less, so you have to be more careful with high speed. You have to be more careful, and now the gaps are less. So it may happen. There's a chance that when you decide to change your lane, you don't find the gap. It can happen now. Okay, the gaps are becoming less and less now. Okay, so there's a chance that you may disrupt other drivers. You may cause them to stop. Okay, there's a chance now. Okay, but as far as you are driving in your own lane, you feel that I can maintain my speed. Here, from level of service B, the change is not only in the driver mind. The change is also is now coming into traffic as well. Okay, in terms of speed. So from A, B to C, the change was only in spacing or the gaps. Here, the change is in gap is so much that it is changing the driver speed as well. Got it? Okay, so in level of service B, you start to see the change in or a major change in driver speed. Got it? Yeah. So obviously, that also means the gaps are less, and there is a very high chance that you will disrupt other drivers. Okay, for changing the lane or because of something with your car, you are looking at the board, now you have to slow down because you have to read the date of the offer. From 25 March to 26 March, right? Something like this. Okay, so this may disturb the other drivers now because they don't have the gap. They are slowing down because of it. You can imagine how less is the gap. The gap is now around 150 feet. Okay. And then we have level of service C, or level of service E, which we said is what? Capacity. Capacity means what? I gave the idea, right? The whole room is full of chairs. Okay. So if I have to move here, okay, I can do it. Okay, because this is my space. But I have to go to the door, I have to move the chairs. Same thing on the road. You are moving in your lane, no problem. Your lane is moving. But now it's very full, so there is no gap. You decide to change the lane or somebody decides to change the lane, you have to stop. There is no other way. That's why it is not sustainable. This is not continuous because there is no gap, literally no gap. It's not like the gap is less. There is no gap at all. That's why we call it capacity. So in this case, even normal changes in lane will cause a stoppage in flow. Even normal ones. That's why they are never continuous. Because drivers need to do other things, right? Okay, so they are never continuous. Okay, and obviously, if they are not continuous, that also means that anything happens, a car broke down, accident happened, it will definitely cause a traffic jam. Okay, and the spacing is now around 100 feet or so. Okay, and now you may say 100 feet means 30 meters. Okay, which is good enough for a car. Okay, a car is how big, you know? How long is a car, you know? How many meters?
2 point something meters.
No, this is long.
3.6.
Huh?
3.6.
Hey, good. 3.6 is good, right? Long. How long? Like from front to back, how much? You are giving me side to side. I'm saying the other dimension. How much is the other dimension? You know? Almost double. Okay. 3.6 is 7 meters. Okay, so 30 meters for a standing car is enough. If I give you 30 meters of space, maybe you can park 3-4 cars there. Okay, clear? Maybe you are more expert than me. Then yes, I need 30 meters for just for myself. Okay, I cannot do it. So, but for a moving car, this is not enough. This gap is not enough for a moving car to enter. Okay, let's keep this in mind. And then when we say 115 feet, sorry, 115, yeah, 117 feet is the gap, and then we are saying no gap. No gap for a moving car to enter. Because a moving car needs a space on both sides, right? You cannot just enter like this. Okay, inside traffic. You need some space before, you need some space behind as well. Okay, so 117 feet is not good enough for a moving car to enter. Okay, if I give you 117 feet to park, more than enough, no problem. Okay, so this is according to them. Any questions? Okay, so next time we'll inshallah start with some calculations and so on.